Right, hi guys. Tonight we're going to continue with rotations, but this time we're going to be rotating an image around a fixed point. So we're going to be identifying a rotation image. Okay, so we're going to take a look at regular polygons. And a regular polygon is a polygon that is equal angular, meaning all angles are equal in measure, and it's also equilateral, means all sides have the same length. In the case of a regular polygon, the center is the point that is equidistant from each vertex. So our vertex here on this triangle, or pentagon here, penta, these are our vertices right here. Here's our center, and the distance from the center to each vertex is equidistant. So since we know that this pentagon is broken up into 5 identical triangles, we know that full rotation is 360 degrees, so there are 5 triangles. 360 divided by 5 is 72, so each individual angle here is 72 degrees. So if we want to rotate image E 72 degrees about X, X being this center point right here, a rotation of 72 degrees, and again we're going counterclockwise, we rotate E 1 turn, we get E, P is the image of E. So to determine how many degrees is 1 turn for each rotation, we just take the number 360 divided by the number of triangles inside the regular pentagon, and we get 72. So 72 degrees is 1 turn for this regular pentagon right here. So let's take a look at example B. Name the image of P for a 216 degree rotation about X. So we know that 216 divided by 72 is going to give us 3, or 72 times 3 is 216. So this means that we want 3 rotations about X, X being the center of rotation. So here's our center of rotation right here at X, and this means we want 3 rotations, or 3 turns, to make 216. So 3 turns would be 1, 2, 3, and N is the image of P. So if we rotate P, it's going to end up right here at N. So let's take a look at this example right here using the pentagram above, or the pentagon, sorry, above, penta. Name the image of T for a 144 degree rotation about X. So we know that 72 times 2 will give us 144. So that means 2 rotations. And again, we are going counterclockwise unless otherwise stated. So 2 rotations about the center of rotation, which is X. If we are taking point T, which is right here, 2 rotations, 1, 2, point T will now, point T is now point E. So the image of point T after a 144 degree rotation about X is point E. Okay, now we're going to take a look at triangle PST. In the diagram below, to the right, O is the center of equilateral triangle PST. We're going to state the images of point P, S, and T for each rotation. So let's just take a look at what all this stuff up here means. So if we look at number 1, R sub R O and then comma 120, what that means is that this means O is the center of rotation, and we are going to rotate each point, P, S, and T, are going to rotate 120 degrees. So where does the 120 come from? So let's go take a look at our triangle over here. So O is the center of triangle PST, and again, O is equidistant from each of the vertexes. So since this is 360 degrees, and we have three triangles, each rotation is 120 degrees, and that's where the 120 comes from. So 120 degrees is one rotation. So we're going to go back over here. Let me make this smaller so we can see the whole thing. O is the center of rotation. We are going to rotate each point, P, S, and T, one rotation counterclockwise. So that means, so we are going to rotate P, S, and T. So point P, one rotation counterclockwise. The image would be point T. Point S, one rotation counterclockwise. The new image is point P, and point T, one rotation of 120 degrees counterclockwise, is point S. So if we look at this next example, again, we have a center of rotation at O, but it's a negative 120 degrees, so that means 120 degrees clockwise. So it's one rotation clockwise, and we are still going to rotate P, S, and T. So point P, one rotation clockwise, maps to point S. Point S, one rotation clockwise, maps to point T. And then point T, one rotation clockwise, maps to point P. And finally, the last one, which is 360 degrees. So 360 degrees really is just coming around full circle. It's three rotations. So we are going to take a look at P, S, and T again. So 360 divided by 120 is three rotations. So we're really just going to end up at the same thing. So point P, 1, 2, 3 ends up at point P. S ends up at point S, and T ends up at point T. Okay, so the examples on the bottom name each image point for the center of rotation. So these look a little bit different than the examples above. So I'm just going to write out what this means. This means that the center of rotation is T, so T is the center of rotation. So it's no longer the O in the middle. We are going to rotate around T, and I'm going to redraw this triangle just so it's a little bit easier to see since the other one has so much stuff on it. So here is our triangle PST. O is the center, and again we have those three triangles, and there's O. But now our center of rotation is at point T, which is right here. So we need to know the measure of the angle at point T. And since this is an equilateral triangle, angle T, I'll write it over here, angle T is 60 degrees. So 60 degrees is one rotation when the center of rotation is T. If angle T was 80 degrees, which it wouldn't be, but let's say angle T was 80 degrees, then one rotation would be 80 degrees, and so forth and so on. So we are going to rotate point S. We're going to rotate point S, which is right here. Sorry, my marker's not working. Point S, one rotation where the center of rotation is T. And we're going counterclockwise. So point S, its new image point, is going to be point P. So in example 2, our center of rotation continues to be T, and this time it's a negative 60 degrees, and we want to rotate point P. So negative 60 degrees means we're going to go clockwise direction, and we rotate point P negative 60 degrees. We end up with point S as our new image point. Okay, in this last example, we are back with the center of rotation being O, so we can use the diagram up above. So we need to rotate point P 240 degrees around the center of rotation, which is O. And remember, we said that 120 is one rotation, so I'm going to write this out. So what we're going to do is rotate P 240 degrees around the center of rotation, which is O. And since 240 divided by 120 is 2, that means 2 rotations. And again, we're going counterclockwise. So point P, which is right here, 1 rotation ends up at T, 2 rotations ends up at S. So our new image point, point P, maps to point S. Okay, now we're going to take a look at this diagram below. We have 3 diagrams here. We have this large triangle AGD, we have the quadrilateral JKLM, and then we have the hexagon IBCEFH. And these are all regular, which means that all sides are equal and all angles are equal. So let's take a look at the hexagon first. And in this hexagon, I just want to draw some angles here, and my thing is not behaving. There we go. So if we look at the hexagon, here's our center of rotation right there. We have 1, 2, 3, 4, 5, 6 triangles. So since a full circle is 360 degrees, and we're looking at the hexagon here, let me change my ink color because that's hard to see. It has 6 inner triangles. So 360 degrees divided by 6 is 60 degrees is each rotation about the origin, which is point O. So each rotation is 60 degrees. So if we look at 120 divided by 60 equals 2. So this is 2 rotations. And we're going to take point B and we're going to rotate it twice counterclockwise. So that's 1 rotation, 2 rotations, and point B, and I'm going to write my answers over here. So point B in number 1, it's the image of its point after a rotation of 120 degrees around O. Its new image is point H, or vertex H. So number 2, 300-degree rotation of line segment IB with the center of rotation, again being the origin, or the point O in the middle. So if we look up right here, IB is right here, so we're rotating the entire line segment. And again, each rotation is 60 degrees. So 300 divided by 60 is 5, so we need to rotate this 5 times. So 1 rotation, 2 rotations, 3, 4, 5, and so for number 2, when we rotate line segment IB 300 degrees around the origin O, it maps to line segment BC. Okay, number 3, a 60-degree rotation of E about O. So here is vertex E. Again, 60 degrees means one rotation, counterclockwise, one rotation, E maps to C. So number 3, the new image is, it's C. Number 4, 180-degree rotation of JK about O. So now for JK, I'm going to erase some of this stuff here so we can see it, because JK is that quadrilateral in the middle. So it's not erasing everything, but it's erasing most of the stuff. Okay, so let's go back over here. So JK is this line segment right here. So since we're dealing with a quadrilateral now, here's our center. We end up with 4 triangles. So 360 divided by 4 is 90 degrees. So for this quadrilateral, one rotation is 90 degrees. And in number 4, we're doing a 180-degree rotation divided by 90 is 2 rotations. So we are going to rotate JK 2 rotations, or 180 degrees, about the origin, which is O. So we're going to take JK, which is this line segment right here, and we're going to rotate it once and then twice, and the new image for JK, I'll write it over here, for line segment JK, just to save space, I'm going to write underneath it, its rotation, it ends up at line segment ML. And finally, number 5, the center of rotation in this case is not O, it is angle H. So if we look at angle H, we need to figure out how many degrees angle H is, and that will tell us how many degrees are in one rotation. So here is angle H right here. We know since this is an equilateral triangle that this is 60 degrees and this angle here is 60 degrees, which makes angle H 120 degrees. So what that means is that 120 degrees, where H is the center of rotation, 120 degrees is one rotation. So we are going to take point F and rotate it once about with the center of rotation as H. So one rotation for point F about the center of rotation being H, one rotation will bring point F up to point I. So F maps to I. Okay, now it's your turn to answer some questions. Which of the 4 polygons shown below does not have rotational symmetry? So which of these, when you rotate, will not produce an identical image? And number 2, a clockwise rotation of 60 degrees about point P maps R onto what point? So P is our center of rotation, and we're going to rotate it 60 degrees, rotate R 60 degrees, and we need to see what the new image is. So it's either going to be S, T, V, W, or Q. Be sure to put your answers in the Google form. Have a good night.